Hello, this is Keith Graham from Codasip. I'd like to introduce you to Assignment 6, Data Hazard Detection and Data Forwarding. Before we talk about it, let's first review pipelining. Pipelining is one of the 8 great ideas of computer architecture discussed by David Patterson and John Hennessy in their textbook, Computer Organization and Design, the Hardware-Software Interface. The idea of pipelining is that an instruction requires a lot of different resources. Now, if we can break those resources into unique tasks where each task has a unique set of resources, when one instruction moves from one task to another task with its own unique set of resources, another instruction can be in its prior task because it has a set of unique resources that do not overlap with the first instruction. So we can have more than one instruction in the pipeline as long as each instruction is using a unique set of resources. Now, if any instruction does not require the result of a prior instruction, we can have a full pipeline, have 5 unique instructions in the processor at one time. Now, the problem is a compiler cannot always guarantee that we can have 5 instructions in a row that doesn't require the result of a prior instruction. Now, let's see how this would potentially cause us an issue in terms of performance. Now, if we take a look at one add-I, and the result of that I needs to be used by another add-I, the result of the first add-I will not be available until after the write-back stage. After the write-back stage, the result of the first one will be in the register file so that the second one can actually read it in its decode stage and then move it into the execute stage. Now, if we don't have any special hardware to detect situations for data forwarding and hazard detection data forwarding, we're going to have 3 intervening instructions that aren't dependent upon that X3 result. And if we don't, we're going to have to throw a no-op. No-op does no useful work. And if we have instructions that are in the pipeline that do no useful work, our performance of our CPU design will lessen. We are hurting the performance of our design. So we want to remove this dependency of one instruction from the result of a prior instruction. And we do that through data hazard detection and data forwarding. Now, let's take a look at how we could actually do, or when we can do, data detection and data forwarding. Now, we know that data is available after our result of our ALU. So the ALU is in the execute stage, so we know that each pipeline will have its result, unless it's a load, and that's a special case we can talk about in another assignment, that the value of the instruction is in the pipeline, but maybe not in the register file after each execute stage. Now, since the data is in the pipeline, it is available to be forwarded right into the ALU because it is available somewhere in the pipeline. So now let's take a look at the case where the bottom add instruction. Well, the bottom add instruction, if it requires a result of a prior instruction, the instruction that's right above it, it can actually grab it through the memory stage right here. Now, if it requires the data 2 clock cycles back, it can grab it through the write back. And it's going to be doing the data forwarding right into the execute stage through a mux in front of the ALU, and that's how you're going to be able to do those 2 forwarding from one of those two pipeline stages. But if our data dependency is 3 clock cycles back, for example, this add-I here, we have a special case of data forwarding because the data forwarding in my execute stage, the data doesn't exist in that instruction anymore. But the data was not available in the register file until the instruction on my bottom add is actually out of the decode. So I actually need to do the forwarding from the write back stage into the decode stage. So that's a special case of data hazard detection and forwarding that you'll learn how to handle in this class. So once again, there are multiple data hazard conditions from the clock cycle right before it, 2 back and 3 back in terms of a 5-stage pipeline. So this assignment will show you how to detect those, how to prioritize which one to forward, and actually how to forward it. If you like this video, please subscribe to this channel so that you'll be notified when additional videos are published. Good luck in assignment 6.